Okay, as we move from chapter 1 into chapter 2, one thing you're going to notice is that there's a shift from kinematics to dynamics. Kinematics is simply the study of how things move. And we've already handled a lot of this stuff, and a lot of these you should be familiar with. When you describe the distance that an object has moved, that's describing how it has moved. And when you describe how the rate at which it is moving, that's essentially speed or velocity. And those are things that you should be familiar with. Again, these are just describing how things move. When you see a moving object, if you can measure its motion, that's kinematics. To actually explain why it is moving in the first place, that is a field called dynamics. And sometimes you're talking about things that are not moving. So for example, this mass. I've got a little metal mass here, and it's not moving. You might ask yourself, why is it not moving? And it turns out it's Newton's first law. An object at rest will remain at rest. This is an object at rest, and it's going to remain at rest unless acted upon by an outside unbalanced force. Now, a lot of this chapter and the following two chapters are going to deal with forces, and I'm going to explain about what forces are. If I look at this object, it's not moving, not because there are no forces acting on it. There's actually a couple of forces that are acting on it. There is the force of the Earth that is pulling on this mass with a force that we call weight. Okay, when you hear the word weight, weight is a force that the Earth exerts on any mass. And it turns out that force is measured in newtons in the metric system. So the Earth is pulling on this thing with a force that we call weight downward toward the center of the Earth. So why is it not moving? If there's a force that's acting on it, because it's not an unbalanced force. It turns out this string is exerting a force upward. So it's called a tension force. And it turns out in this case, the force of the Earth pulling down is equal to the force of tension pulling up. And therefore, when I add those together, it winds up giving me 0. Okay, those are called balanced forces. So an object at rest will remain at rest unless acted upon by an outside unbalanced force. I do have forces here, but they're balanced, and therefore my object at rest remains at rest. Now, how could I unbalance the situation? I can bring along my friendly neighborhood scissors. When I cut the string, the Earth is still pulling on the weight, or on the mass, with a force that we call weight. But when I cut the string, I'm going to remove the tension. So right now I'm in a nice balanced situation. Weight equals tension, and therefore my object at rest stays at rest. An object at rest will remain at rest unless acted upon by an outside unbalanced force. Notice that when I cut the string, the tension went away. The Earth was still pulling on it. Now I had an unbalanced situation where I had the force of the Earth pulling downward and nothing pulling up. Now I'm in an unbalanced situation. My mass went from being at rest to being in motion. One thing I'll mention right at the outset is that Newton's first law is pretty easily remembered. You probably remember Newton's first law just as, an object at rest remains at rest, perhaps from an earlier science class. Everyone remembers this one. They may not remember that it's Newton's first law, but they know the wording. The object at rest remains at rest. That's pretty much common sense, and very few people have a hard time with that. If you put a football out in a football field, it's going to just sit there and sit there and sit there. An object at rest remains at rest unless acted upon by an outside force. If some joker comes along and kicks it, obviously it's going to go from being at rest to being in motion. So a lot of folks don't have any problem with that part of Newton's first law. The problem that it conceptually gets difficult in daily life is an object in motion remains in motion. Because if you take a chair and you give it a shove, that chair is going to stop. It doesn't remain in motion. And that's where Newton was brilliant. Among many things, Newton was brilliant, but he had the insight to realize that there's a force called friction, which we're going to deal with more in chapter 3. It's not really going to be a topic for module 1 material, but we will be touching on friction. But Newton realized that you shove that chair and it doesn't remain in motion because there's an extra force. There's a force called friction that acts on it. So as it's moving along there, it's being acted upon by an outside unbalanced force, and that's why it goes from being in motion to coming to rest. And we're going to deal with this more in chapter 2 or in chapter 3, module 2, but just keep that in the back of your head.